CRD 3.4, graphing two variable quadratic equations. So in 3.1 and 3.2, you learned how to factor quadratics, and that was all dealing with expressions. Okay, so you just basically learned how to manipulate the expressions when you have a quadratic and factor them. 3.3, you were solving quadratics, so now it was an equation. It had an equal sign and something on both sides. And you were factoring and setting it equal to 0 and solving a quadratic equation. Well, now in this lesson, we're going to graph it. Okay, you learned how to graph linear equations in crocodiles and coconuts. Now we're going to learn how to graph two variable quadratic equations. And in fact, we will revisit this again in chapter 5. So basically, by the end of algebra, you should know quadratics through and through. So graphing, let's go back to what we learned in CC, graphing two variable linear equations. So remember, this is a linear equation, y equals 2x plus 5. I know it's linear because it has x to the first power. So that tells me it's linear or a straight line. It resembles, and in fact falls into the pattern of y equals mx plus b, where m is 2 and b is 5. Let's remember that b is the same as the y-intercept, which is 5. So 1, 2, 3, 4, 5. I put my first point right there. And then my slope is the same as rise over run. And it's 2, so I can make 2 into a fraction by doing 2 over 1. So I start at the point of 5, and I go up 2 and over 1. Up 2 and over 1. And I don't need 100 dots, I just need 2 or 3. And then I get a ruler, and I can connect them. Okay, and then I have a lovely graph. So this is graphing a two-variable linear equation. Hopefully that felt easy to you, because at this point it should. Now, if we take a look at this one right here, can you predict the shape of this graph? Well, you should be able to, because you should know that it is a quadratic. And whenever x is squared and y is not squared, you should know that is the shape of a parabola. And a parabola is a U-shaped curve going up or down. And we talked about narrow and wide and all those things, which I'll remind you about on the next slide. Now, you have never graphed a parabola in this form. However, if you were asked to, let's say you took a test somewhere else that had nothing to do with HILA, and somebody asked you to graph this. You could do it. You could always make a chart, an x and a y chart, put in some values, -2, -1, 0, 1, 0, 1, 2. Plug in the value -2, make it so it's -2 squared minus 2 times -2 minus 8. You get 4 plus 4 minus 8. You get 8 minus 8. You get 0. So you actually have the point -2, 0. So you could start by plotting that point. -2, 0 would be right here. And then you do -1 and whatever that gave you, and 0 and whatever that gave you. And then you would construct your parabola. So you can always do it by chart, but we want to find faster ways because the chart is tedious and long. So we want to find faster ways to do it. So let's remember our vertex form. Y equals a parentheses x minus h squared plus k. I would look back at your CC 4.4 notes to self because those will show you vertex form and what everything stands for. I'm also going to remind you, but it could be helpful to have that out when you're working through this lesson. Okay, I have an x and a y, of course. My x is squared. So this right here tells me it's a parabola, okay? The a part tells me if it opens up or if it opens down. Remember, if it's negative, it opens down. If it's positive, it opens up. And then if it's a big number, it's going to be extremely narrow. And if it's a small number, like a fraction, it's going to be wide. The other thing is the HK. The HK gives me the vertex, which is a really important point on a parabola. It's the point, the lowest point or the highest point if it's an upside down parabola. So HK is a very important part, and it's kind of where the symmetry is created from. Some people say HK. As long as you have a minus here, you can say the vertex is at HK. Other people see this as negative HK. They look at the number right here, and they say it's going to be the opposite of that. I'm comfortable with either one as long as you're getting it right. So if I look at this first example, I see that my A term is 1. I know it's a parabola because it's x squared. So I know that this is going to open up, and I know it's going to be standard width. Now, if it's going to be the opposite of h is -1, so my vertex should be at +1, and then it's going to be at -9. So my vertex is at +1, -9, which is right here. Okay, very important point in the graph. 1, -9, also known as the vertex. Okay, and then what we did from there in CC4 is that we plugged in values to figure out what the other values were. Okay, we made a chart and we said, let's think of something that's close to 1. How about 0? If I plug a 0 in, I'm going to get 0, 1 minus 1 squared, which gives me 1 minus 9 is -8. So that would be another point. So 0, -8 right here. And then I know it has symmetry, so it's going to be right here. My parabola is not perfect on this. And then I come up with some other points and I find that symmetry, and then I draw my sketch. Okay, so that's one way to do it. Well, now you're going to be given parabolas that are not in vertex form. Okay, and maybe you won't be able to get them in vertex form. But something new that you can do is you can substitute in 0 for y. Now, if I do that, basically, I'm coming up with points. Remember, points go x comma y. I'm coming up with points that have 0 in the y coordinate. And you'll see I'm going to get 2 of them. These are actually called the x-intercepts, not the y-intercepts, but the x-intercepts. So look what I have here. I have a quadratic formula in standard form that equals 0. So what I'm going to do is I'm going to factor it. And I'm going to solve it. And I'm going to get 2 values, 4 and -2 for x. Now both of these are true when y is 0. So my point 4, 0 and -2, 0 are going to be the x-intercepts on the graph. So 4, 1, 2, 3, 4, 0 is right here. -2, 0, 1, 2, 0 is right here. Those are both my x-intercepts on the graph. Okay, extremely helpful. Let's move on to the next slide. Okay, now I don't have anything in vertex form, and I don't know how to get it in vertex form. That's something you'll learn in chapter 5. So what can I do? All I can do here, I can't use my quick vertex form to do anything. All I can do is put a 0 in for y. So if I put a 0 in for y, and then I write my equation, and then I factor 12, 1 and 12, 2 and 6, 2 and 6 will work. Plus 6 minus 2. I set x minus 2 equals 0. I set x plus 6 equals 0. I get x equals 2 and -6. So what does that mean? Remember, those give me the x-intercepts. So my x-intercepts are 2, 0, because remember, y was 0 and my y is 0 here, and x is 2. And then I get another one at -6, 0. So if I find that, it would be right here and right here. Well, I know it's a parabola. I know it opens upward because this is positive, but I don't know what the vertex is because it's not in vertex form. So how could I figure that out? Well, I know it has symmetry, okay? So where's the middle point on this? This is basically 8 spaces long. So if I count 4, 1, 2, 3, 4, I know that's going to be the middle. So I'm actually going to drop a dotted line down, okay? 1, 2, 3, 4. Because I know that that is where my, kind of messed this up. I know that that is where my vertex is going to lie on. Okay, it's going to lie on that point. Uh-oh. Okay, so I'm going to make my dots a little bigger so I don't have to start this over again. I know it's at 1, 2, 3, 4. It's at that point and this point. Okay, so I have my x-intercepts. I know that's the middle. If I fold along that line, it should match up. So I know along that line that x equals -2. So basically, if I take -2, I plug it back into my equation, which I need actually. My equation is y equals x squared plus 4x minus 12. I'm going to take my -2, plug it in here. I get 4 plus -8 minus 12. That gives me -4 minus 12, which gives me -16. So my vertex is going to be at -2, -16. Okay, well, does that fit on my graph? Let's see. I don't know if I have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I know it's going to be down further, and hopefully the graphs on your paper can go that far. So once I find -2, 16, then I can connect my points. I could actually add more points if I wanted. I know I would have 0, -12, and then I could find this one. The reason I know I have 0, -12 is because I just did a quick mental math, plugging in 0 here, and I know that's going to give me -12. So my parabola looks terrible. I know you're going to do a much better parabola on your paper. So let's move on to the next slide. So what you're going to be asked to do in this is basically graph parabolas based on this format. Now notice I have leading off here with a negative. So that's immediately going to tell me something about my parabola. It's going to tell me that it opens downward. It's not in vertex form. So I'm going to first replace y with 0, and I'm going to solve for x. So 0 equals -1 x squared plus 4x plus 3. Notice how I factored out a -1. Leave the -1 out here. Factor this. X plus 3, x plus 1, all equal to 0. 0 has to equal x plus 3, or 0 has to equal x plus 1. Solve, and I get x equals -3 and -1. So I know my x-intercepts are at -3, 0, and -1, 0. So there's -1, 0. There's -3, 0. Now, how do I find my vertex? Well, I know it's got to be directly in between there. So what's directly in between there? Actually, it's -2. I've graphed this wrong. Okay, so -1, 2, 3. So I know this is going to be pretty skinny, and I know it's facing down. So I'm going to pick x equals -2. It's the same one as before. And I'm going to find out what the y component is for -2, because I know it's got to be along this line, and it's going to be up here somewhere. So I plug in -2. I've got y equals negative, that's right here. Now my x is -2 squared, minus 4 times -2, minus 3. A lot of negatives here, so be careful. Negative, and that gives me 4. And this is 2 negatives, so plus 8 minus 3. So -4 minus 3 is -7 plus 8 is 1. So y is 1. So my vertex has to be at -2, 1. And does that fit with what? Yes, it does, because it's got to be above the x-axis. And now I know my parabola faces downward. Okay, most of this lesson you're going to be just finding the x-intercepts, but it is important to figure out how you could find the vertex if I asked you to. Good luck.